My name is Silvestre Pinho. I'm a professor on mechanics of composites at Imperial College London on the Department of Aeronautics. And my research is on the understanding of the physics of the mechanics of composites during failure. So I try to predict how they fail by first looking at the physical mechanisms from an experimental point of view, and then developing both analytical and numerical models that I then typically implement in Abaqus to predict the response of realistic composite structures. The biggest challenge is perhaps to translate solutions which work very well on a very simple problem at a very small scale into solutions which are quite comprehensive and work on large problems on a large scale with industrial relevance. And the challenge there is that you can't really just focus on one specific feature that you know is the one that matters. You have to be able to include several features and their respective interactions. And you need to be able to have models that are not just accurate, but are also robust and are able to scale very well so that you can have both scales, the scale of the problem you want to analyze and the scale of the discretization that you need working well together. The benefits of using Abaqus for us is that we can focus on developing our own material models or our own code, our own new science within the context of a very complete suite of software, which includes all type of features, all state-of-the-art, without us having ever to worry about that. We know that everything is functioning around the little bit where we are focusing greater depth. And we also know that at the end of the day, when we have new models and new features and new capabilities, those are already implemented in a code which is widely used by industry, which means that the impact of whatever we do is much larger if we are doing it in a code like Abaqus, where we have a very large set of companies that can potentially use the code.